There are some projects, but I don't think anybody's doing it as comprehensively as we are. Like the other also sort of new or nascent or whatever browser projects are taking existing components from other browsers to some extent. So you have Servo, but they take a lot of components from Firefox, like they take the JavaScript engine, the CSS engine, stuff like that. And then you have a proprietary browser called Flow in the UK, but they're also building on top of Firefox's JavaScript stuff. We're building on our own JavaScript engine, our own CSS, our own HTML, our own everything. And we're trying to stick to the spec as much as possible because it makes life easier and ostensibly more compliant, competent browser as well. So far, so good. You were talking about like about the simplicity or whatever of the different specs, I think, or you kind of touching on it, like implementing JavaScript is hard or implement CSS is hard. Like which part is the more complicated thing? And I just wanted to touch on that briefly, that JavaScript is surprisingly easy to implement, we've found, because it's so well spec'd and so well tested that it's pretty easy to stand up a new JavaScript engine from the spec, and it will work with most of the JavaScript that you throw at it from the web, with one big notable exception that we keep hitting our faces on repeatedly, which is...
Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Andreas Kling, creator of two of the most prominent Scratch-built projects I'm aware of, SerenityOS, which is a Scratch-built operating system, and the Ladybird browser, which is a Scratch-built browser. We talk about some of the surprising challenges that he's run into, also some of the benefits that you might not expect from being able to start from scratch, even when you're up against teams with millions of dollars and lots of people working on them. We also talk about how standards end up being, in some cases, designed, and in other cases, evolved from de facto things that just sort of appear in the wild. Finally, we end up talking about a topic that both of us have in common as an interest, but which I haven't actually gotten into much in this podcast, which is powerlifting. I want to give a huge shout out to everyone who's been supporting Software Unscripted on Patreon. Thank you all so much. I really appreciate it. If you've been enjoying these episodes and want to subscribe, please check out patreon.com/softwareunscripted. And now, here's my conversation with Andreas Kling. All right, Andreas, thanks for joining me.
Thanks for having me, Richard.
Okay, so you originally created Serenity OS, and something I've always been wondering is, like, how do you, in the modern world of so many different hardware configurations and all of these different driver considerations and stuff like that, how do you start from a blank page and actually make an operating system that works?
Well, the strategy that I employed was to just target virtual machines. So in the beginning, when you're building an OS from scratch, you don't really want to be testing on a real hardware anyway, because of the tedious boot loop and everything, right? So de facto, you end up running on virtual machines. So it just made sense to target the hardware that was in the popular VMs. So QEMU, obviously, was the logical one. But in the beginning, my previous pet project before SerenityOS was an x86 emulator. So I had my own emulator that I was sort of hacking on in tandem with SerenityOS in the beginning. So a lot of the debugging I was doing was like editing the C++ code of my x86 VM to inspect the state of the operating system. So it was a very strange, unusual situation.
So you were building both ends at the same time, in some sense.
Yeah, in some sense, yeah. I mean, the VM I had was already pretty functional. Like it could run old Windows and old Unixes and stuff like that. But it had pretty immature hardware. Like I did a good job with the CPU and the MMU, I think, but the hardware was all over the place. So that's why I ended up moving on to QEMU eventually, because like trying to target my own badly implemented PC hardware was not the most reliable way to build a new operating system.
Well, okay, but even if you're targeting a VM, you still have to deal with things like, okay, I want to make the keyboard work for real from scratch, and all you're getting in from the keyboard is ones and zeros, and you have to translate all those into like actual, keystrokes and stuff like that applications can understand. So, as I understand it, you have, I guess in the very old days, you would have a relatively small number of, keyboard formats. Let's just stick with keyboards for a second. And you could kind of understand, like, okay, well, if I get these ones and zeros, they correspond to these numbers, which I can interpret in these ways. But then at some point, you get so many different varieties of those that you get the sort of like plug and play movement. I have a very shallow understanding of all this.
Sure.
Um, and so at some point you get to things where like the keyboard itself is telling you like what its drivers are, and so do you have to sort of like support that in your operating system like before you can actually use like arbitrary keyboards? How does that work?
So for the basic peripherals, like keyboard in particular, but also like the display, we are standing on the shoulders of giants a bit with everybody still wanting to support like old DOS, old Windows, stuff like that. Like even today, people don't sell a PC that doesn't actually run old Windows
Hmm.
um, because I guess there is a business case for that. And so because of that, like the every BIOS out there essentially configures itself in such a way that you can speak to the keyboard and the display in a unified way, even though they're like completely different devices than they were 30, 40 years ago when these BIOSes were designed. So we've been kind of piggybacking on that essentially emulation layer very much in the beginning. So like we didn't have fancy graphics for a long time. We just sat on top of sort of BIOS emulated VGA. But obviously, VGA was a standard a million years ago that is not actually how video cards work now, but your computer still emulates it for the sake of old systems. So yeah, so we sat on top of a lot of stuff like that.
Interesting. Okay, so I'm reminded of like way back in the day, you had this PS2 port for your like in the pre-USB era, and it was this kind
Right.
of round thing that had like a couple of like very very visible pins. And I remember that yeah, like when you plugged that thing in, it had some weird properties. Like if I remember right, I think if you unplugged and replugged the keyboard, you had to reboot before it would recognize it. So something about
Right.
like during the actual like boot sequence, that was when it was like, okay, there's either a keyboard here and I can figure out how to talk to it, or there isn't, in which case there's no keyboard forever. And if you unplugged it, that was kind of game over.
Yeah, there's a lot of interesting sort of idiosyncratic things like that that we inherited from the original IBM PC. If I recall correctly, another really goofy thing is that the keyboard and the mouse, I think they share like a buffer, and so you have to be sure that the thing you're reading is like from the mouse or the keyboard based on state that you have to keep track of. And if you screw that up, like you end up interpreting one as the other, and
Oh
that's
no.
yeah, like these goofy bugs that we've had over the years, where like, oh, our mouse reading code got a little out of sync, and suddenly you touch the keyboard and the cursor moves and stuff like that.
Right.
Um, Good stuff.
Yeah, I mean, I'm sure there was like a performance reason for that. Some like hardware limitation way back in the day when you
Right.
had kilobytes of memory to work with and stuff like that.
Yeah, exactly.
The
It's just
the
it's just
Go
an
ahead.
interesting historical artifact, right? That the IBM PC ended up being the thing that so many other manufacturers cloned. It was just like at for whatever reason at that point in time, we took a snapshot of the very popular IBM PC and cloned it in a million ways, and then that became sort of the standard. And that's still the thing that you start by targeting when you build a new OS from scratch today. Is the easiest thing to start targeting is the IBM PC.
Yeah, it's funny how standards oftentimes end up being sort of organic evolutions of something that was just popular versus like somebody sat down and really planned it out and thought it through. Like I think about something like IP and TCP as being much more planned, and then something like JSON is just like no, just like somebody, it was convenient. Somebody came up with it, and now it's this extremely popular standard. Not because anyone sat down and was like, what will be the optimal textual, like human readable representation of stuff is JSON. It was just like, no, you can use eval and JavaScript, and so it can be fast, by default. And then one thing leads to another, and now it's every language is expected to support it.
Yeah, it's fascinating. I mean, you have sort of like human languages, right? Like you can divide them into descriptive and prescriptive languages, and I feel like a lot of technology standards are kind of the same. Like some standards are really just codifications of things that evolved organically, like fungus on the internet, and other things are more planned. Like somebody sat down and thought, "How do we make this thing good?" Um, and I'm not really sure that one is better than the other. I think there are pros and cons. The web is a glorious mishmash of both planned and unplanned such standards. So
Well, it's funny because you can look at any given standard you don't like and criticize it from either direction. Like you can either, if you don't like it and it was very planned, you can say, well, see, this is what happens when people get together in committees and they don't think about the real world. They just design everything in a smoke-filled room somewhere. And then on the flip side, when it's, something like JSON that emerged organically, you can look at that and criticize it and say, well, this is what happens when you don't plan anything.
True. Very true.
Yeah, I mean, at the end of the day, like we have the standards we have, and then we have to either deal with them and work around them, or ideally try to improve on them incrementally. And maybe when that's not possible because it would break backwards compatibility or something like that, then try to come up with a new one somehow, or maybe a new one just emerges organically.
Yeah, yeah. I mean, so one of the big criticisms that we always got with Serenity OS was that we're not trying to invent new things as much as some people would like. So a lot of it was like, hey, here's a fun standard that every computer supports. It would be nice if we also supported that. And like the obvious ones being like Unix, like it's a sort of basically Unix compliant or Unix like operating system.
Like POSIX?
Like POSIX, yeah. Like we put quite a considerable efforts into POSIX compliance. And there's like this category of nerd on the internet who's deeply offended that somebody would build yet another Unix operating system. Like, how dare you? Because it's been done before, and they would really like to see something else at this point. And I have endless messages from people like this, just sort of chewing me out for building another Unix.
Well, this is very familiar to me too. It seems like when you create something and it starts to get some traction, there's a whole category of people who are like, I'm upset that your thing is getting traction and you didn't set out to build what I wanted you to set out to build.
Right.
Like in this case, as I recall, your goal with Serenity OS was mostly like it was a fun hobby project. It wasn't like you were trying to revolutionize anything. It was just like, I want to build this thing because I want to experience what it's like to build a thing like this.
Yeah, basically, yeah. Like it was a like a personal therapy project that I had just to stay sane as I was learning how to live without drugs and alcohol. So it was like a post-rehab project. And I really just wanted to build an operating system. And then I thought, hey, it would be kind of sick if it was like a Unix, but it looked like Windows 2000. Wouldn't that be awesome?
Yeah.
And then I just went for it. And I mean, it ended up resonating with a whole lot more people than it ticked off, obviously. But the human mind is like that, right? Like you get 1,000 compliments and somebody says you're an idiot. What are you going to remember?
Yeah. I mean, I think that is one of the challenges of you could say it's open source work, but I think it's just kind of building stuff in general is just like, yeah, there was a quote that stuck with me from Rich Hickey about this, which was something like, like you put something out there, 1,000 people say this is really nice, and one person says something negative, and the metaphor that he uses is like it only takes so many arrows to bring you down, like eventually. Even if you 10x or 100x that, it doesn't feel like, oh, I got 1,000,000 nice things said about me and I got 1,000 negative things. It's like 1,000 negative things is just so many to deal with. And I understand why a lot of people walk away and put down projects and say like, I don't want to do this anymore. And I think that's usually the reason is it's the barrage of negativity that only amplifies as the project gets more popular.
Yeah, for sure. It was kind of luxurious in a way with Serenity OS because we never actually released anything. It was kind of understood by everybody, at least everybody who worked on it, that it was meant to be sort of a developer Zen garden kind of thing where you could just like come home from work, sit down and poke around with all this stuff.
Yeah.
And there was nobody breathing down your neck. There's like a wide variety of different interesting problems to work on. I think if we had sort of a release cycle and non-technical users or less technical users than developers, it might have become more stressful sooner. But it never did for me, at least, so that was good.
Yeah, I mean, it's great to set expectations like that when obviously, some people on the internet won't respect those anyway, but at least among the people working on it to say like, hey, like, this is what this is for. This is what our goals are. This is what we're trying to do here. And not like, let people come to it with their own understandings or guesses about what the goals are, and then be unpleasantly surprised. Yeah, that is a tricky thing about managing any kind of sizable project where people are collaborating on it. Is just like, does everyone understand like what the expectations are here? It's easy to take that for granted.
Yeah, and also I think in that particular space, like open source operating systems, there aren't really that many centrally managed operating systems. In fact, I can't even think of one off the top of my head right now. Maybe Haiku is like that. It's the closest to centrally managed, because like everybody else is pulling like a million other open source projects, right? Pulling them in and building on top of them, like sort of making a patchwork out of all kinds of third-party sources. And Serenity was unusual in that we did everything in-house. So like everything, no third-party code.
And that's where the
And
browser
yeah,
came from, right? You wanted to have your own browser.
exactly. Yeah, so the browser was just like a byproduct of Serenity OS should probably have a browser to be able to browse the web, but we can't just build an existing browser. That would be lame. So let's build our
Where's
own
the fun in
browser.
that, right?
Right. Yeah, and then it kind of spiraled out of control a little bit.
Yeah.
It
So how
became
did
its
that
own
happen? I
project.
mean, it seems like Ladybird, talking about project goals, it seems like Ladybird has a pretty different goal than just like this is a fun thing to hack on after work, compared to Serenity OS, where it came from.
Right. Yeah, it's very very different. So I am originally like a browser developer by trade, I suppose you
Hmm.
could say. So I used to work on browsers at Apple for a long time, and at Nokia before that, and then on open source browsers before that as a hobbyist. So I've been doing it like my whole career, more or less, building browsers with little breaks here and there, but it's been the majority of my stuff. And um, I thought I was done with browsers, and I was happy building Serenity OS. I was happy making like little photo editing apps and little text editors and stuff like that, little GUI markup languages. But then we started adding a browser to it, and it was, like old circuits in the brain just started lighting up. And damn it, this is so much fun. Uh, and then, before you know it, I'm putting 100% of my time into this browser, and kind of starting to forget about the rest of the operating system.
Now, is this something where you actually do want to try to make Ladybird like the best browser out there? Like you have like performance goals, or like user friendliness goals, or security goals, or privacy goals, or is it like you want it to be competitive but kind of your own flavor, and it's more a matter of taste than anything else, or fun, or what are the goals?
So the goals are fluid, let's say, but we want to build a competent browser that can browse the contemporary web as it sits. We don't want to be one of those browsers that says like, "Oh, sorry, we can't render this because we don't support WebGL or whatever."
Mm.
We want to be able to handle the web, like the real web as it exists. Now, of course, websites may decide that they don't like us based on the fact that we say who we are, but there's only so much we can do about that. But we want to build a competent browser that has reasonably good performance, and responsiveness. And when I talk about performance lately, I've been thinking of it in new terms, because I always used to think of performance in terms of numbers, like, oh, it's this, it runs this benchmark in this time or whatever, or it's like 2x faster than this other browser at this. But lately, I've been sort of reorienting myself, and thinking about it, in the terms of, if you never notice it, it has good performance.
Hmm.
Performance is fast enough that you never think about performance. The moment you
Right.
start thinking about performance, you have bad performance. Um,
I love that. Yeah, I
yeah,
mean, when it comes to user interfaces, it's not about throughput; it's about latency. It's like, and about perceived latency. It's like,
right.
I don't care if, like, if you're rendering it, 10 times as fast as my eye can process it. I don't get any benefit out of that. My eye still only can process it that fast. However, yeah, if it feels laggy, if it feels like, yeah, if I notice, you know, if I ever say to you, I wish the performance of this thing were better, that's because I noticed it.
Yeah, exactly, exactly. So I think perceived performance is a huge thing. And there's a lot of smoke and mirrors the browsers do already. Like the shipping major browsers like Chrome and Safari and Firefox, they do so much trickery to get you to feel like everything is fast, right? Like there's so much caching. Um,
Right. I remember
and
reading
yeah.
something about I think it's like text inputs, like they have a separate rendering like just for the like when you type characters into the currently focused text input, it's like it gets a completely different like fast lane like rendering pass that's totally different from like everything else that's going on the screen, or so I've heard.
Uh, that was certainly the case many years ago. I think nowadays that optimization sort of became the starting point for a series of optimizations that
Hmm.
generalized that kind of partial update. But at least in Safari, it was one of the very first things where we did sort of partial relayout of the page, because it's such a common use case that you're typing into a text box and you know for a fact that nothing outside of the text box is affected by sort of the layout work that happens inside of it. So
Hmm.
um, I think that was the first case of partial layout updates in Safari and WebKit. And now in Ladybird, we don't do partial layouts yet, and that's sort of the first area where it looks like an obvious place where we should do it, because it's super tedious to type into a text box and it's laggy.
Yeah.
It's you
Nobody
definitely
wants that.
like notice performance when you're doing that.
Yeah.
Um,
For sure.
yeah.
This is like one of those areas where it's kind of weird because my experience has been there's a little bit of I don't know what the right word is, amnesia or something like that, but like I remember back in the day that when I used to use IDEs, like Eclipse and IntelliJ IDEA and NetBeans, like way back in the day, I remember them feeling laggy in comparison to things like I don't know, I get back then it would have been like TextMate, maybe Sublime Text, and I didn't get into Vim until later. But yeah, like I'm in the comparison is like, oh, this could feel instant, but now I know that it doesn't. Um, Similarly, today when I switch back from Zed, like which I work on, to like a VS Code or something because I'm trying it out, like, oh, this, the competition shipped a new feature. Let's go see how it works. Yeah, it feels laggy, but I used VS Code for years and didn't notice it. So it's like now that I know what it can be, it's hard to go back. But but back when I didn't know that was available, I guess I always kind of did because of Vim. Like when I was using like Vim in a terminal that was low latency, then I could tell the difference. But now I actually to the point where I actually am annoyed by Bluetooth keyboards. Like I need my keyboard to be plugged in because if it's over Bluetooth, I can tell like there's like just it's the slightest amount of latency, but and I this is not just me cork sniffing. This was like I got a new keyboard at one point and I plugged it in and I started typing and I was like, this feels slow. Why is this keyboard so slow? And it turned out that the cable was actually just for charging and it wasn't actually sending data. It had just automatically used the cable to connect to Bluetooth, and that was how it was sending the data. And like I didn't know that it was doing that. I just assumed because I plugged it in, it was using the cable for data. But I felt it and I was annoyed by it. And I went to debug why does my keyboard feel laggy, and that turned out to be the answer. But I don't think I used to be that sensitive to it because I definitely also like 10 plus years ago used a Bluetooth keyboard and was like, oh, this is fine. So I don't know. There's something about like once you get used to something being a certain amount of fast, it's annoyingly easy to get used to that and not be able to go back.
I guess so, yeah. But I think it kind of goes both ways. Like you can slowly boil yourself into accepting latency as well, right? You sort of, especially, I feel like nowadays that so many AI features have been added to coding. What do you call it? Editors, I guess, coding editors or whatever. So you have this sort of built-in latency where you're waiting for some kind of lookup or some kind of completion or whatever. And that makes the little UI lag that you would get from using Java or something microscopic in comparison to waiting for the internet, waiting for a
Yeah,
GPU somewhere in Palo Alto or whatever. Um,
I
yeah,
need to write
so
a blog post about this, but it feels like we're in the dial-up era of like large language models, by which I mean, like, I remember back in the early days of the internet, the latency was so bad. I mean, it would just take like 10 seconds to get your web page across the across the telephone line. And so yeah, it really just felt like a fundamentally different experience when you got broadband and everything felt relatively instant, like in comparison. And it seems safe to assume that eventually we'll get to the same point with large language models, just because one of the only reliable trends in the history of computing is that hardware gets faster and cheaper by some metric. Even if that is like, not CPU clock cycles, but like, more cores, whatever. It gets faster and cheaper over time. And so if that trend continues, then eventually it stands to reason that you should be able to get the same quality of model output as you get today, except much, much faster, hopefully to the point where you're not sitting there waiting for it to spool out. You just like type your thing, press enter, and it's like, but here's your answer. I did the thing.
Yeah. I'm going to go out on an edgy limb here and say I think it's also a slightly reliable trend that software gets a little more complicated and a little slower as a result.
Yeah. To go back to the plug and play example, you could say like, well, there's all these different peripherals that want to do all these different things, and so that's where the complexity comes from. Then the slowness is a byproduct of trying to accommodate all that complexity of the use case. But I think a lot of the slowness in software and a lot of the complexity comes from just this sort of general thought of like, hey, wouldn't it be more ergonomic if we did blank, without really thinking about, okay, but what are the performance trade-offs of blank? It's just thinking about just only in terms of what feels ergonomic to the programmer, and that being kind of either the only consideration, or the people designing those APIs don't necessarily know what the performance or complexity trade-offs will be, or like aren't fully enough aware of them that it only becomes apparent after it's too late.
Yeah, I think that's a fair analysis. I've recently been thinking that complexity is sort of a direct consequence of increased headcount in many cases. Like you add people, engineers or PMs or whatever, to any kind of software project, and you just get more code. And the more code tends to, it's not all greenfield stuff, right? So you have to sort of work on existing structures, and then you sort of just try to reinforce those or generalize them and to try to make better abstractions and all of this stuff that a smaller team wouldn't spend time on, because they would be sort of focused on whatever the core mission of that code is. And that's also one of the things that we're trying to figure out in the Ladybird project, especially within our nonprofit that receives donations and employs people to work on it, is we're not particularly rich, so we're never going to have massive headcount.
Right.
And so we have to find ways to build browsers with a tiny team. And it's interesting because there are these big companies building browsers as we speak, but they all have the benefit of millions and millions of dollars. And it looks significantly different when you take that out of the equation. And I think it forces us to justify complexity in a way that I think our competition is not used to.
Yeah, I was going to say, there's an element of, on the one hand, there's the benefit of having millions and millions of dollars, and then on the other hand, there's also the curse of having millions and millions of dollars, which is that, you're expected to spend it, and what are you expected to spend it on is, a larger and larger team. And yeah, I do think there's an interesting element of like looking at like what are the projects that you think of are really, really impressive from a performance perspective, and how many people worked on those. And it seems to me that when it comes to performance in particular, there is kind of an inverse correlation there. That's pretty coarse grained, but like usually the really, really impressive projects are generally come out of a smaller team when it comes to performance. I'm thinking again in the web dev world of like the Elm programming language had a very, very fast compiler, and it was made by basically one person with like a little bit of help here and there. Very reliable, like very fully featured. But yeah, like one person just doing all the performance optimization, being careful about things, and making his own data structures for for things. I think about like something like Go also has a very good reputation for performance among garbage collected languages, and it's like not. I mean, has a much bigger team than Elm does, but it's nowhere near like C++ with like a standards committee and like all the people working on GCC or Clang or anything like that. And then I think about like Zig, like comparatively very small number of people making a much faster, compiler than other people. And yeah, I mean, that's all just like within the world of compilers, but it's not, it wouldn't surprise me if it turned out that Ladybird was able to be a faster browser than a lot of these alternatives, just because you have a smaller team and you're naturally inclined to spend more time thinking about performance, be more careful about it, and yeah, be able to resist whatever complexity comes from having a higher headcount.
Yeah. So it's complicated. I think we can definitely be faster at some things, but the big browsers have basically like they have huge teams and they have huge complex code bases, but they've sort of brute forced themselves into good performance anyway, by just throwing like countless compiler PhDs at their JavaScript compilers, by like just aggressively throwing people at performance optimizations and like having this sort of culture of rewriting things to make them faster. And it's, I think they are incredible feats of engineering, all browsers. If you look at the sheer complexity of what they have to handle, the fact that they work as well as they do is astonishing. And it's unlikely that we would ever be able to compete on raw numbers with any of the major browsers that exist today.
Well, I mean, okay, so maybe when it comes to benchmarks, that's maybe that's true. But I will say, I mean, like Bun would be a good example outside the browser of like you look at it's like Bun compared to V8, compared to like I don't know, Node.js, right? Node.js is way more funding, way more people working on it, etc. Bun kind of comes out of nowhere. It's extremely small team, and but they had the benefit of being able to start from scratch, and also we've learned more things about I don't know how to do performance well, like data oriented design, thinking about cache misses are the big problem, the biggest problem, I guess, and just being able to organize everything from the start to be sort of like with that with those performance characteristics in mind and those strategies in mind, I think is a big help. Like we're doing this big rewrite of the Rock programming language compiler, and just the fact that we're able to do everything in a data oriented kind of way, like structive arrays everywhere, indices over pointers, that type of stuff, is a huge deal, and it's really hard to like retrofit that incrementally into an existing code base. I think being able to start from scratch means that you can get a certain very large category of very important, very valuable performance optimizations that are just really, really hard to not only implement incrementally, but also if you've already got a huge code base with tons of features, if you're trying not to regress anything, I mean, good luck.
Yeah, yeah. Compilers are a fun space to work in, it sounds like, because you get to make up a lot of your own data structures. You get to design sort of your own algorithms however you like, as long as the outcomes are what you want. It's great freedom, right?
Yeah, I
I
mean,
like that.
we do have some constraints. Like interoperating with other languages is kind of an inevitability these days. Like in the case of Rock, that's kind of an explicit goal, but pretty much every language needs to be able to like talk to C code somehow. And so you do have like some limitations there. And I would imagine if you're working on like a JavaScript engine, you have way more limitations in that you need to support all sorts of use cases that come up in practice, even though if you were designing your language from scratch, you would say, well, these are just not allowed because they're horrendous for, trying to make it optimize a compiler.
Yeah, yeah. I mean, we're looking at a thing right now, which whenever I talk about it, it makes people sad. So we've been UTF-8 sort of native since the beginning. And now we've gotten to the point where we feel that we have to switch that and go UTF-16,
Yep.
uh, which is like cool, great, very exciting project.
Right.
But the frickin' web is UTF-16 first.
Sure
JavaScript
is.
is UTF-16. All the APIs work on, UTF-16 code unit offsets and stuff like that.
Yep.
And we have been shuffling bytes and stuff around behind the scenes just to get you, like, to translate indexes from UTF-8 byte stream index to UTF-16 virtual index and whatever. And there's like 1,000 places where we do it wrong, and now we're just kind of saying, this is stupid. Let's just go UTF-16.
Yeah.
Um, this is like, yeah, so that's definitely an example of like
It's right.
constraints
It's
imposed
not
by
what you
the
want,
space.
but yeah, it's right. I mean, it's funny because going back to the discussion about like protocols and how they evolve organically, the language server protocol specifies UTF-16 for all of its offsets by default. Why is that? Well, we know exactly why that is, because the reference implementation was in TypeScript, and TypeScript is built on JavaScript, and JavaScript is built on the web, which means UTF-16 for historical reasons. Like there was this one window of time, which unfortunately happened to coincide with the internet taking off, where like UTF-16 seemed like the best idea. And now, of course, everybody uses UTF-8 for everything, except for if you're doing Java or JavaScript or Windows APIs. Like those are the ones that all use UTF-16. They're just sort of locked into this decisions that were made right during that window of time.
Indeed. And, I still feel like we haven't seen the best string API yet. Like, it's yet to be discovered. Because I was pretty excited when Swift came out, and they were sort of oriented around grapheme clusters instead of
Yep.
just giving you code points or bytes or whatever. That felt like, hey, innovation in string APIs? Really? There's more to be had, and maybe there's even better stuff. I don't know. But yeah, it's a bit anticlimactic to go from UTF-8 to UTF-16. But at the same time, when we look at that particular problem, once you get over the hump of like, well, UTF-8 everywhere is good, right? You start to think about what are the sort of points where you're interacting with the OS where you actually need UTF-8. Like if you're going to set a window title or save a file to disk or whatever, I don't know.
Well, which OS? Because if you're Windows, you need UTF-16 for those things.
True, yeah, right. Depends on the OS. But like when you actually boil it down, there aren't that many places where you actually need UTF-8. And so we told ourselves a story about UTF-8 in our code base, at least, that wasn't entirely factual. And it's kind of nice also to find that it was a little bit just riding on the hype of UTF-8 being cool. This is just me coping with
Yeah,
UTF-16.
Well, I'm in the same boat where like we have this compiler. Rock does everything UTF-8 by default, but people want to use it in the browser via WebAssembly, and at that point you're like, okay, well, now we're sort of priced into converting all because DOM strings are UTF-16, so that means that we have to at the boundary convert all the UTF-8 to UTF-16. Now here's where things get really kind of like mind melding is like, okay, so if we're just talking about like making strings for buttons and stuff like that, you could make an argument that like, okay, we should just be UTF-16 native and that's kind of the end of it. But you could also make the argument that, well, if what's really going on here and like really being expensive is like the string processing, maybe it's actually better to have all your string processing in WebAssembly and UTF-8, and then only at the very end, the last thing you do is convert to UTF-16. Maybe that's a net savings compared to having all the string processing being UTF-16. So it really, it's not even like one is better than the other just because that's what the final API that you're going to talk to expects. It's also about, well, what are you doing with it in the interim?
True.
But then you get into stuff like, well, okay, but what kind of string processing specifically are you most likely to be doing? And in the browser, that's probably JSON, and the JSON is probably coming over to you from JavaScript in UTF-16. So you got to convert that from UTF-16 back to UTF-8, and then you can do your parsing on it, at which point are you still saving stuff? So yeah, it's a whole big pile of considerations that are very annoying.
Yeah, that's for sure. I think the most common text processing we do or string processing is actually like looking up font metrics and like figuring out how much space does this word take.
Yeah.
Where do we hyphenate? Stuff like that. So it's like a mixed bag because every web page finds a new way to irritate your browser engine. And that's the beauty of the modern web is that like everybody sits on top of these frameworks like React or Vue or Next or whatever, but um, the frameworks they go up to like 95%, and then above that mark sits the special sauce that makes every web page unique. And somehow they all manage to do one little thing that nobody else does. We're having fun finding those. Um,
Any fun examples come to mind recently
Recently, so the last couple
or
of
ever?
days, yeah, sure. No, I was just thinking, like, what am I doing right now? So the last couple of days, I've been working on Discord. So getting Discord to work in our browser, or getting it to work better. And they have a particular way of clipping images so that they have round edges. So like all of the like user profile picture, when you see in the chat, like you see the profile picture next to whatever somebody says, it's rounded corners. And the way that they implement that is that they take the image, put it inside of an SVG, and the SVG has this mechanism called a foreign object where you can put HTML inside your SVG. So what they do is they put an SVG with a foreign object that has a div that has an HTML image element that has the image, and then they use SVG to put a mask on top of this foreign object substructure. And it's like, I haven't seen this before. It's really interesting combination of features, but the web platform has these features, and um,
I'm sure I'm
turns
missing
out, yeah,
something really obvious, but what's wrong with like border radius for making your corners round?
yeah. Discord, what is wrong with border radius?
That's like, isn't that? I mean,
I don't know.
anybody who was doing web dev long enough ago that we remember making transparent PNGs and then like doing repeat X and repeat Y to make rounded, borders on your things using images. Remembers IE7 supported border radius, and that was such a huge deal. Like that's obviously what I would reach for, but I don't know. I don't work on Discord, so maybe there's some reason.
I think it's part of a more generic grader system here, because like this is just one of the many masks that they apply to images. So they might put like a little online indicator on top that's like carved out, so they make like a little hole for that. And so they do a lot of clipping and masking of stuff, and they do that by putting like image HTML images inside of an SVG and using SVG features to clip and mask and stuff. And there's just a lot of coordinate math to deal with. And it's like my nemesis is coordinate math. I never liked it, and yet I make my life about building browsers, which are like 30% coordinate math. But it's getting better. I have it clipping correctly now, so that's good. Just took about a week.
That that example reminds me of, there's this whole category of I don't know, design space when it comes to protocols or standards that other people are going to have to implement, which is basically just like, you can take something like SVG and it's already a pretty big enough standard, and then with just one little sentence you can make the complexity of the whole standard explode, which is something like, and you can put HTML in there, right? It's like, and all of a sudden it's like, just the amount of implementation effort needed just absolutely skyrockets, especially if, I mean, in your case, you're building a browser, so you already support HTML, but imagine if someone's trying to just make a SVG viewer, and they're like, I'm going to just be able to take some SVG out of a web page, for example, and just display it here. It's like, oh, now you're on the hook for an entire browser rendering engine because of that one little line that's like, by the way, you can put HTML in there. It's
Indeed.
frustrating to me when I mean, I'm sure somebody thought about it at some point and thought about the downsides, but man, does that ever seem like the type of thing that I wish were not part of SVG in the browser.
Yeah, SVG is it's an interesting example actually to talk about, because it's kind of the spec itself is not really evolving. They have kind of stopped editing it. They're barely merging bug fixes to it, and I don't know why that is, but as an implementer, it's a little bit weird because it feels kind of outdated compared to other specs. Other specs are more aggressively kept up to date with each other and sort of just kind of evolve over time. But SVG has been relatively static for a long time. And there are a lot of little things in the SVG spec that don't actually match what browsers do. Um, I just found like random stuff just yesterday. I found like, oh, in the spec it says that you should do this, but no browser actually does. And
Right.
somebody changed the spec in 2016. Before that, it matched what the browsers did. No justification. So cool.
Well, okay.
Um, yeah.
We can contrast that. That is to say, a spec that doesn't get any new additions ever with JavaScript, which so something I've always wondered about trying to implement a new browser from scratch or a new JavaScript engine, and I guess this would apply to CSS as well, and HTML for that matter, is so on the one hand, I've heard the point made that existing browsers have this gigantic moat around them because there's just so much to support that just pages and pages. If you tried to print out all the specs that you're responsible for, to make a new browser from scratch, it would be this, take up a warehouse or something. I don't know, but huge amount of surface area. On the flip side, I can also imagine how quite a lot of these could be implemented in terms of each other, in terms of like, if you have Flexbox implemented for CSS, you can, I would assume, implement something like float or this or that, like in terms of that. And so it's not as if you have like 20 different things that all have to be implemented from scratch, rather that you have a couple of, really powerful primitives that you really have to get right. But once you've gotten those right, the others can be implemented in terms of them. I don't know. What's your experience been when it comes to things like that?
I think, I mean, those particular examples don't really line up with reality, unfortunately. Floats are
Bummer.
incredibly mysterious and strange. Um, but
Right.
but there are definitely parts that can be implemented in terms of each other. And nowadays, with the specs being sort of aggressively maintained by so many people, even the specs sort of suggest, hey, you can implement this in terms of that. And they go and do the work of like writing the specs so that features are implemented in terms of other features, which is of great benefit to us, obviously, because then we
Yeah.
just have to build what the spec says to build. Um, and in many ways, that comes out with us having much nicer code than the older browsers because they implemented all this stuff before the specs told you, hey, you can just build this core feature and then stack these things on top.
Right.
We've had the benefit of all that spec work, which is really cool. Um, yeah. And we've been very aggressive in Ladybird to try to keep our code base looking like the spec as much as possible, wherever it doesn't like severely sacrifice performance to do so. And that ends up with a pretty interesting looking code base that has like spec text in line as comments all over the place. And it's a bit of a maintenance burden because like when they change the spec, we have to try to keep that up to date.
Sure.
But it also makes it a lot easier to orient yourself. Because if you've read the spec, you can find the same place in our code, and then hopefully it will look very similar.
So okay, so sort of breaking it down, it sounds to me like, just putting together the two previous things that we talked about, that contrary to what I would have guessed, it actually sounds like getting the fundamentals right is actually a lot harder than getting the very long tail of very specific APIs that you have to support, right? Or is maybe that just a function of like where the project is right now, and maybe in the future it'll be a lot more about the long tail of mysterious miscellaneous APIs?
Yeah, I think you're right. It's probably a function of where the project is right now. I would say the specifications are in general better than they've ever been. And they are very comprehensive, very good coverage, very good technical documents that you can, for the most part, sit down and implement a browser from the specs. People have a lot of outdated sort of mimetic knowledge about like, oh, browser specs are bad, they don't match the browsers. There's all these unspec features, or browsers do all kinds of things that the specs don't say. But that's like ancient stuff from Internet Explorer times, when that was the case, right? But since then, there's been just a Herculean effort by spec people to actually document what browsers do and turn these things into implementable documents. And we are now doing sort of the first real big smoke test to see what happens if you sit down and implement these specs.
Yeah, I guess so. There's not really anybody else that I'm aware of that's actually trying to build a fully compliant, I think you said competent browser.
Right. Right. Compliant and competent. No, there are some projects, but I don't think anybody's doing it as comprehensively as we are. Like the other also sort of new or nascent or whatever browser projects are taking existing components from other browsers to some extent. So you have Servo, but they take a lot of components from Firefox, like they take the JavaScript engine, the CSS engine, stuff like that. And then you have a proprietary browser called Flow in the UK, but they're also building on top of Firefox's JavaScript stuff. We're building on our own JavaScript engine, our own CSS, our own HTML, our own everything. I would try to stick to the spec as much as possible because it makes life easier and ostensibly more compliant, competent browser as well. So far, so good. You were talking about like the simplicity or whatever of the different specs, I think, or you kind of touching on it, like implementing JavaScript is hard, or implement CSS is hard. Like, which part is the more complicated thing? And I just wanted to touch on that briefly. That JavaScript is surprisingly easy to implement.
Huh.
We've found because it's so well spec'd and so well tested that it's pretty easy to stand up a new JavaScript engine from the spec, and
Wow.
it will work with most of the JavaScript that you throw at it from the web, with one big notable exception that we keep hitting our faces on repeatedly, which is date parsing, because it's not spec'd.
Wow. I never
And
would have
this,
guessed that was the problem.
yeah, it's the main problem with JavaScript compatibility that we have on the web, I would say. Where we just keep stepping on a rake and getting a new date format every time. And it's because in the spec it says ISO 8601 is the only date format you have to worry about. And you can
Uh-huh.
support others, but that's an implementation detail for you.
Uh-huh.
And then all the other browsers support like a ton of random
Oh
formats.
no. Oh, that's the problem.
Yeah.
Okay, so basically it's not that the spec doesn't tell you what to do, but rather the spec was a little bit too lenient, and now
Mhm.
because all these other browsers have chosen to run with that, now you're in practice on the hook for all the different formats they decided to support because people used them. Yeah.
Exactly. And then, like there are people at the major vendors aware of this. There are people working on the spec, they're aware of this. But I think it's just nobody wants to sit down and document this horrible thing. Like take the V8 date parser and reverse engineer it into a spec. Like that's not fun for anyone.
Right.
So it just doesn't get
Oh.
done.
Yeah, that's rough. And yeah, I never would have guessed that, but I'm now that you say it, it makes sense. Wow. So okay. But there is, of course, this separate sort of mountain that we talked about earlier, which is it's not sufficient in a lot of cases to just have a JavaScript implementation that's correct, but also one that runs fast enough that people don't notice a difference. You do get a boost from hardware manufacturers, making better and better hardware. Less so on phones. I actually don't know if. Do you have any aspirations to put Ladybird? I know Android allows you to do your own rendering in a browser.
Sure. Yeah, we have some aspirations. They're soft aspirations at the moment, but like, why the hell not?
Sure. Yeah.
And we've had a Android build at one point in the past, but we never got it scrolling up and down. So that tells you how far we got on that. But it could
Do you
render.
really need scrolling though? Just
I don't know. I mean, usually the important stuff is in the top left corner of any web page.
I personally I never read past the headline anyway before leaving a comment, so that's my policy.
There you go. Yeah, but so we've had it building on mobile in the past on Android, and thanks to the EU, Apple has been forced to create sort of a browser engine kit that you can use to put a new browser engine on iOS.
Oh, I didn't know that.
because in the EU, they're not allowed to restrict browser engines
Hmm.
like they are in the US. So here, in theory, we can put it on iOS as well. Um, but they have a bunch of like requirements to let you do that, and so we don't qualify in all those other ways yet. But it's
Hmm.
something that we're kind of loosely working towards, because why the hell not? Let's
Yeah.
see if we can run on iOS one day. Um,
So then you do get
yeah.
into JavaScript performance being a bigger deal because the CPUs that you're working with and the amount of memory that you have and the performance of all that is obviously much lower on a phone than it is on a desktop computer.
Yeah, for sure, for sure. Uh, and the interesting thing about JavaScript, though, is that I would say in the vast majority of cases, performance, like raw performance and throughput, is not really that important. Most
Hmm.
web pages don't run a lot of JavaScript. They run like a little bit, and um,
Is that still true? Because I always thought with like the rise of React and like rendering everything in JavaScript and stuff like that, that you would get a lot more of that, but maybe I'm wrong.
I mean, there's more, but it's not a painful amount, I would say.
Hmm.
Um, the so we don't have like a super fast JavaScript engine by any means. We have like a simple bytecode VM, um, non-optimizing, so we don't do any kind of compiler optimizations whatsoever. We just like spit out a bytecode and then go interpret it
Interpret it,
basically.
yeah.
And we have like like the basic interpreter optimizations like threading and stuff like that, but we don't do anything fancy, and that still gets us what I would call performance that you don't notice on most web pages.
Wow.
Um, but there is the case, of course, when you go to a web page that is JavaScript heavy, that sometimes you end up noticing it a little too much. And we are looking for ways to improve those kind of things. So, for example, Google Maps is one. They do a fair amount of processing
Mm.
in JavaScript, and we've been doing a bunch of optimizations for that. But still, most of the optimizations tend to be in our runtime, because very often, like the JavaScript, the raw interpretation of the JavaScript is like fast enough, but then they make some runtime call like, hey, sort this array, or like join this array with a comma between every thing or whatever. And then we've implemented that in like some stupid generic way, and
Uh-huh.
there's opportunities to improve there. So I'm hopeful that we won't need to get super fancy with JavaScript. That would be really, really nice, because I've worked on other browsers in the past, and the complexity of something like JavaScript Core or V8 is just, I would say, it's to a detriment of the hackability of those projects.
Yeah,
Uh,
to say the least, I can imagine.
let's say. And we are extremely hackable at the moment, probably in many senses of that word. But
I think you might have some vulnerabilities in there somewhere.
I'm sure we do. Um, and that's also something that we have to, get better at. But the hackability, I think, is super valuable to us, because it means that you don't need to be a browser developer expert with like industry experience or whatever to get started working on our code base. You just need to be reasonably experienced with programming in general, and then you can pick up the spec and pick up our code and figure out how to get started. And we're like onboarding new people all the time, and people who've never touched browsers before, never touched JavaScript engines, and I think that's really cool. And it's very unusual that the major browsers can do that because of the like intense complexity of their code bases.
Yeah, I don't know if you think about these things, but I have seen some speculation recently that a series of events that might unfold is that Google gets forced to sell off Chrome. If they sell off Chrome, Chrome does not make any money. It just costs a lot of money. The only reason Google does it is so that they can have Google be the default search engine. If they're legally forbidden from doing that, they have no reason to fund Chrome anymore. They also have no reason to fund Firefox anymore, and Firefox is Chrome's like major competitor, at which point you have Safari being the most funded browser, and Apple, generally speaking, as I understand it, is mainly funding new Safari development just to keep up with Chrome and Firefox. I guess that leaves kind of like Edge, and so we're sort of like back in the 1990s era where it's like Microsoft is the one funding all the browser development, but maybe they don't care either. And so now all of a sudden you go from a world where you have multiple major multi-million dollar browser initiatives to zero, and then suddenly all new development on browsers kind of stops, maybe except for Ladybird, because you're a small enough, low enough overhead, independent organization. Do you ever think about like what if if all those things come to pass?
Right. I mean, it's fun to think about for sure. Um, I think it would be sad in general, like as a human being who likes to use the web for stuff. It would be sad if browsers died. Um,
Well, I don't know if
if
they
we
would
take it to
die.
the
I mean,
extreme.
even
No,
if they
but
stopped getting new features, I don't think that would kill the web. Certainly.
no, it wouldn't kill the web, but it would be a different kind of web. Like the spirit of innovation, I guess, would move elsewhere. Let's say. Um, and where that would be, I don't know right now. But I think the fact that so much is being invested in the web, R&D for the web, right, by all these big companies, it means that there's a sort of gravity of innovation happening, like sucking innovation towards it. Um, and that would be sad to see that go. I think at the same time, what we do to me is a very valuable exercise, not just for the fun of like building a new browser or because it's so cool, but um, we are trying to take these specifications and see if we can implement them at like competently, but at like way less cost than what has been done before. And the big meme in the tech industry has been that like you can't build browsers anymore. Like it's not possible because they've gotten complexity has gotten out of hand. Look at Microsoft; they had their own browser engine, but they gave it up because it was too hard to maintain or whatever. That whole narrative is spooky, I guess. And if we show people that you can actually implement this stuff reasonably well with, less than 50 people with not $1 billion, I think that that opens up a lot of interesting questions. Like, okay, what have we been doing here? Like, can we streamline this whole thing?
Yeah, I'm reminded
And
of one of my favorite Chris Latner quotes, which was I don't remember what the interview question was, but what he said was, people told us it was impossible to make a new C++ compiler to compete with, GCC and MSVC. And what he said was, it turns out it's not impossible. It's just very, very difficult.
yes, 100% agree.
Yeah. So, I mean, but there is an important gap there, right? Between impossible and very, very difficult. A lot of things that are very, very difficult turn out to be very, very worthwhile as well. So I'm glad that you're doing what you're doing. I appreciate
Right.
you're making there be one more browser in the world that was created from scratch and not a fork of an existing one.
Yeah, yeah, and if you look at what happened with LLVM and Clang and all that stuff, I'd say the world is much better off for it. So many great things have come out of that, and I don't know what will be sort of the end effect of the Ladybird project. Will it become a web browser that a whole bunch of people end up using, loving, and it just provides something great for the world in terms of like a piece of software that you just use? Will somebody fork it and make a better browser than we could do? I don't know. Will our engine become the foundation for something? Or, I don't know. I don't know. But I think the world. I hope that the world will be better for us going through this exercise. Um, an interesting side effect that we're seeing a lot, um, which is hard to see from the outside, is that by testing these specifications and like actually implementing them, we end up finding issues that we report, and we work with spec people to fix those issues, and we're sort of um, almost like validating the specs, I guess, because that hasn't really been done before in this way. Like people write the specs and they implement the feature in their browser, and then some other browser goes and maybe they skim this back and look at what the API is and implement it in some way that makes sense to them and whatever. And then we're just coming along here, like faithfully going through like each step, like, okay, let's do this and let's do that exactly as they say and see what happens. Um, and yeah, we've like reported tons of spec issues, and the specs are improving as a result. And we're frequently told by the standards bodies that they appreciate what we do. So that's really cool as well. And yeah, so just to add on to that, like maybe the end result of what we do is that somebody else comes along and has an even easier time building a new browser. That would also, maybe all of these things. I don't know. I'm happy if the world is somehow a better place after we go through the exercise of building this browser.
Well, that's a noble goal, and I like I said, I appreciate what you're doing. Anything else we should talk about before we wrapped up? We talked about a lot of different things.
I don't know. What about powerlifting?
We could talk about powerlifting. Yeah, it's fun. I recommend it.
Yeah.
You know what? A lot of people don't know is that what I have read. I don't know if this is true, but it is apparently that of all the different sports in the world, powerlifting has the lowest injury rate. Which, if you think about it, kind of makes sense because it's like you're not moving very quickly. I mean, you're moving pretty slowly, so there's not much opportunity for, I don't know, something like surprising. Like there's no element of reflexes really. You've got safety supports all around you for all the different ways you might drop the weight, so that it's not going to travel very far if you are dropping it. And on top of that, the sort of like way that you're moving your muscles and dealing with like, vertebrae, like for back injuries, apparently a lot of the concern about back injuries is mostly around like twisting, and you don't do any of that in powerlifting. It's like your spine is always like straight up and down. So yeah, I mean, in comparison to like, you might think golf would have a very low injury rate, but apparently golf actually has a very high back injury rate because you're constantly twisting your spine to hit the ball.
Right.
Well, over time, if you're doing like serious golfing, whereas with powerlifting, like, I don't know, apparently even like, Olympic powerlifters are not, Olympics, bad example. Olympic weightlifting is different than powerlifting, but like professional, competitive powerlifters have a lower injury rate than other professional sports.
Yeah. So I've recently been introducing my nephew. He's 10, introducing him to powerlifting.
Wow.
And he has this coach, but his coach got drafted to our national team here in Sweden. So now his coach had to go away to training camp or whatever.
Don't you hate it when that happens?
I hate when that happens. And now he kind of left me in charge of the training. And he gave me this book about like how to train children.
Oh, okay.
And it also talks about this thing that you say, that powerlifting has like the lowest injury rate. And it says that the highest injury rate is soccer, because in soccer, I forget the exact numbers, but it's like something like 6 injuries per 100 hours of playtime or something like that.
Wow.
Which is incredibly high.
Yeah.
And powerlifting had like a fraction of that, like way, way fewer injuries. And in particular, it talked about girls, how girls play soccer and they just hurt their knees so much.
Oh, man.
And it just sounds terrible. And yeah, and there was always this meme in the past that, at least when I was growing up, like I was told, don't lift weights because you'll stunt your growth.
I heard that this is a myth that has been debunked, but persists anyway.
Right. Yeah, exactly. So this book I got, it goes into that in detail, talking about like how the myth, where it came from, how there are these growth plates in your bones, and like if you injure them, then something can go wrong or whatever. But that this basically doesn't happen.
Right.
And it's not something to worry about. And there's all these reasons for kids to do resistance training. And yeah, it's super interesting to try to teach a 10-year-old to lift, because he's learning so much faster than I did.
Yeah. Well, I've also heard that, I mean, obviously, 10 years old is pre-puberty, but I've heard that once you hit puberty, especially for boys, like they've just got so much testosterone that they don't need to do the whole like consuming tons of protein and calories to keep lifting heavier and heavier weights. They can basically just keep going into the gym and lifting heavier and heavier weights, and it just keeps working out thanks to all the testosterone, which I don't know, considering how much I've struggled, like especially I'm about to turn 40, like it's nice to think about, wow, if I just known about this back when I was in my a teenager, I could have made so much more progress so much more easily than I can now.
Yeah, exactly. That's exactly what I'm trying to do for my nephew is like I wish that I had known this when I was a kid, and I wish that somebody talked to me about it and showed me these things exist. So I want to give him the opportunity. Maybe he's not going to enjoy it for very long. So far, he's having fun, but
The wildest story I've heard about weightlifting and bones was it was this guy who fell off a house or something, and so he was really really in bad shape, and the recovery was initially just like kind of okay, take it easy, stay in bed, etc. And of course he put on a lot of weight and stuff like that. And as I recall, the story was eventually he just started getting really depressed because it was like he just couldn't function on a basic level. And at some point he got into weightlifting, like powerlifting, as a way to try to fix this. Oh yeah, also like walking was really difficult, and super painful. He couldn't really like run at all. And apparently what happened was after he did more and more weight training to the point of like, increasing the amount of weight, like the quantity of weight, not the like number of reps, like you're not taking like 20-pound dumbbells and doing it a lot, but rather like, okay, lift 5 pounds, then 10 pounds, then 20 pounds, then 30 pounds. And, you keep going up and up and up. And eventually what happened was he had all of these like metal things in his legs that were like holding his bones back together. But apparently one of the things that can happen is that powerlifting, because you're putting all this weight on your body, reacts to that and adapts to that. And that includes your bones, and your bones apparently get stronger in addition to your muscles getting stronger because they're being compressed and like, oh, we need to like make the bones like, I don't know, stronger, harder, whatever. And what actually happened was that his bones started strengthening to the point where they pushed out the metal that was holding them together. And they actually had to go in like with surgery again to like remove these like pieces of metal that used to be holding his bones together. But his bones just like through the weightlifting, like just pushed it all the way out and like completely healed and were stronger than they were before. And they had to go take the metal out. And then eventually he could like run again and like lead a normal life again. And that to me, like completely upended my understanding of like, I don't know, like, the like, it'll stunt your growth thing, right? It's like, oh, maybe actually it's like if you subject your body to certain stresses that your body actually can recover from and actually can adapt to, actually that makes your body in better shape. Then it's not like you're like hurting your body. It's like you're training your body to like be better. These are things that I'd never really thought about when I was younger. I remember seeing a TED talk where I think it was a professor or something talked about he's like, you walk through the halls of our university and you see these people who treat their bodies as if the purpose of their body is just to carry their heads around. And I was like, oh, I really relate to that. That's how I feel about my body. It's like that's its job. It's just to, like all the interesting stuff happens in the thinking zone. And I don't know, getting into weightlifting really changed my perspective on that. It feels a lot different. It's a lot more interesting than I would have guessed. We don't really talk about that on this podcast, but here we are.
yeah, I think it's a topic that I wish that more programmers would care about or at least take an interest in, because programmers have some of the worst physiques. I've had a terrible physique myself in the past, and yeah.
It's funny you mention that because I actually found out about weightlifting from, of all places, a Hacker News comment. Not kidding. Somebody posted about, I don't know, it was some topic about exercise or something, and someone said, what I like about weightlifting, and he recommended it was strong lifts 5x5, but I later learned it's basically just starting strength but repackaged and doing sets of 5 instead of sets of 3, which doesn't appear to be optimal, but whatever. But basically what he said, the pitch was, he's like, look, it only takes 30 minutes per session, which at the beginning is true, but like now at the level I'm at is not true anymore. But back then it was. And he's like, and you can start from nothing. And the cool part is you're not just going through the reps to like sort of maintain, or it's not like, cleaning your room because it's dirty. It's like you do this for like 30 minutes and, periodically, and then eventually you look back and you're like, oh, I'm strong now. And that's the selling point, is like, it's not just exercise, it's exercise, yes, but also later on you're like, oh, I'm a strong person now, and I never used to be that. And it's cool. I don't know, there's something that like
Super cool. Yeah.
yeah, that like really appeals to me about I'm somebody who just having to like clean stuff is just so annoying, because it feels like you're working to stay in place. And just the knowledge of like, oh, like this is not just exercise, but actually I'm becoming a strong person when I do this, feels great. It's a lot more motivating to me than feeling like, oh, you got to go move your body in these ways, because if you don't, there will be negative consequences eventually. It's just much more motivating to be like, if you do this, you could be a strong person again. I'm like, oh yeah, I like that.
Yeah, for sure. And you mentioned starting strength, and I remember, I think it was Ripito from Starting Strength, who talked about old age, and how old age for an untrained person is like you start just circling the drain slowly, slowly.
Mm.
Your life just gets worse, your body decays and falls apart until you eventually die. But if you train yourself to be strong, then old age is more like you're just kind of driving up against the wall. Eventually, you hit it and die. But there's no circling of the drain.
What an uplifting message.
It sounds better to me.
Well, I mean, like the way I think about it is more like, I'm glad that I don't really need to worry about osteoporosis. At least if I'm able to keep doing what I do. If I get some sort of injury where I couldn't lift anymore, then that's a different story. But
yeah, no, I think just powerlifting just goes well with programming, I guess. That's something that I've found, and I'm always telling people to check it out. But there's a lot of inertia, I guess, in people.
yeah, I mean, I guess since I don't think I've ever talked about it on the podcast before. I guess I'll put it out there that like, I agree with all that. Like, it's really nice. And the pitch was correct. Like, you can spend, at least at first, about half an hour per session.
Yeah.
Do that a couple times a week. If you're following a program, definitely like, you need to learn how to do the lifts correctly. You don't want to just walk into the gym and be like, I see what that guy's doing, I'll do the same thing. You need to actually learn how to do them correctly. Use barbells, don't use machines. And
do starting strength, not strong lifts.
Yeah, starting strength is kind of the gold standard. Yeah, if you want to start having some strength. It's a book. It tells you how to do the lifts correctly and stuff like that. It's kind of dry. I would say the nice thing about strong lifts is just that I don't know. It's a little bit more.
That's user friendly. It's more polished. Yeah, they have the app and everything. I've done SL as well, and I know it's a polished experience, but at the same time, the fat pink Texan man yelling at you that you get in starting strength is just hard to beat.
At any rate, learning how to do them correctly,
yes.
Definitely a good thing. And then, yeah, I mean, like the pitch is real. I mean, granted, I did weigh about, over 300 pounds back then. And I have learned that, weirdly, more body fat makes it easier to be stronger. Also a counterintuitive thing I would not have guessed. But yeah, I mean, I went from, and this was in my mid 20s, from just, I started off squatting a broom. Like I couldn't really do the movement fully yet. And then I went basically from that, just adding 5 pounds every time, all the way up to squatting 300 pounds with almost no interruptions. Just like there was like maybe a plateau here and there. But yeah, it's really surprising how far you can get if you're completely untrained and have never done any kind of barbell stuff, to being like, oh no, I'm a strong person now with, I don't want to say minimal effort. It's not like it's no effort. It's, but it's a lot. It's a way less effort than I would have thought it was starting out.
Yeah. And you feel better about yourself in just a way that you probably haven't felt before.
It does seem to especially improve a lot of small pains and things like that. Like I used to have a lot of upper back discomfort, especially maybe from just like sitting a lot, and I tried like standing desks and stuff like that, and that helped somewhat, but I just always felt, ever since I started lifting weights, that wasn't a problem. And I know that it's the weightlifting because twice I have had, one time it turned out to be a perceived injury, but it actually turned out to be like a weird like cyst or something that, I don't know, needed a doctor to like take care of. And the other time was I tried Olympic weightlifting, and that was a Yeah, that was a mistake. That's the fast kind. I don't have any recommendations for the fast kind. Powerlifting, nice and slow, very good. But yeah, like and those 2 times when I was unable to lift for like months, the back discomfort came back, and so I was like, oh, that was what fixed it. Confirmed experimentally for sure.
That's awesome. Yeah. Cool. Well, I don't want to take up the rest of everyone's time here with talking about
Yeah.
powerlifting, but it is always on my mind lately.
Yeah, well, I appreciate, and you don't get to hear programmers talk about that often, and it's not going to become a fixture of the show, I don't think. But I'm sure
see.
some people will have found it interesting. Some people will have found it boring. Maybe some people will find it life changing. Who knows? Well, yeah. So thanks so much for talking about all these things. It's always interesting to hear about browsers and and like operating system development. These are things that I've never done, but which I'm fascinated to learn about. So really appreciate your taking the time to share your experiences with me.
Yeah, of course. Thank you so much for having me on, Richard.
All right, take care. That's it for this one. I hope you liked it. You can find links to some of the things that we talked about in the description. And if you'd like to become a supporter of Software Unscripted on Patreon, check out patreon.com/softwareunscripted. Until next time.